We still do our, oh my gosh. We still do our width, length, width. We still do the 400 equals 2 widths plus a length. We still isolate one of them. So length equals negative 2w plus 400. We still do that, which is the same as 20-1. Okay? Then what we do is we do max area because it wants the largest area. And it's length times width, which is the exact same as last year. Same steps. And then we filled in for L because that's when I isolated. So negative 2w plus 400 times w. And then we distributed, just like last year, negative 2w squared. Sorry, this isn't max area, this is area. Just area. Negative 2w squared plus 400w. But I want max area. So that's just the area. How do I get max area? How do I get maximum of anything? Take the first derivative, set it equal to 0. Nothing crazy. So remember how we do this awful completing the square over here? Now we just do the first derivative. So if it's a polynomial, life is easy. It's going to be negative 4w plus 400. And then you have, set equal to 0. And you get negative 4w, or just 4w equals 400. Divide by 4. W equals 100 yards. How do I get the length? Plug that into where? Into the length equation, the one we got by itself, right? So we're going to go negative 2 times 100 plus 400. Length equals 400 yards. That says 200. Minus 200 yards equals 400 yards. I mean 200 yards. I went back to it again. Okay. So when we completed the square, our back number was our max area, correct? So now it doesn't directly just give us our max area, but it does give us our dimensions. So how hard is it to find our max area? It's not hard. How do we do it? 200 yards times 100 yards, which equals 20,000 yards squared. Now, did it ask us for the maximum area? Did it ask us for the max area? Or did it tell us to find the dimensions of the rectangle? Dimensions. So I showed you max area because if you can be asked for max area, or you can be asked for dimensions, or you can be asked for both, right? So you didn't really have to find the max area, but I was proving a point that it actually came out to the same as the grade 11 one. Right? Still the same, this back number was our max area. So the dimensions of the rectangular field, guys, stop. Of largest area are 100 yards by 200 yards. All right. So that's a farmer question that you could do. We're going to flip to number 4 next. It's kind of like a farmer question. I'm not going to do this part. We're going to ignore this part. We're just going to treat it like it's a normal question. So here, we also did these in grade 11. It says a rectangular playing field is to have an area of 600 meters squared. Fencing is required to enclose the field and divide it into 2 equal halves. So what does this make? A length, and a length, and a width, and a width, and a width. Painful. All right. It says find the minimum amount of fencing needed. What are the outer dimensions of the field of fencing? So we have 600 meters squared. Find the minimum amount of fencing needed to do this. So what can we do? What does area equal? Length times width, yeah. Perimeter equals 3W plus 2L, yeah. We know that. We know area is 600 meters squared. And then we're going to have to work our way through that. I'm giving you this ahead of time so your brain can think, okay, what if it's an area thing? And we're going to come back to this question because I'm going to give you 2 different types of questions that are optimizations. So keep that one in the back of your head. Okay, let's go back to 2. We're coming back to that one. I just want you to keep it in the back of your head. What could I possibly do to do that question? Okay. Shh. Kyle. All right. So number 2 is very, very, very similar to a 30-1 polynomial question. It is a metal box without a top. It's to be constructed from a square sheet of paper. So now we have a square sheet of paper. And remember in 30-1, it was a rectangular sheet of paper, but it was still the same thing. Remember, there was the dashed lines. Now here it says, from a square sheet of paper that is 20 centimeters on the side. So this is going to be 20 centimeters from here to here. Then from here to here is also 20 centimeters. And then it says, by cutting square pieces of the same size from the corner of the sheet and then folding up the sides. So we labeled those X's. These are all X's. So, for example, okay, so, the struggles with cutting skills of kindergarten have gone over. Okay, so we have a square piece of paper. We agree? Now, if we fold up the edges of the same width, we're obviously going to get a perfect box with a top open. Okay, guys. Okay, so if I take this and I fold it up, I have a box. Right? It perfectly folds to a box with a full piece of paper. Perfectly. Right? Like this is great. Does it? No. They said they cut out a square out of each corner. Paying attention. With your mouths closed. We're going to try that. I believe in you. I don't really, but I'm going to hope in you. So, we cut out the corners. And now we actually can make a box, correct? Because the corners are gone? We agree? That was what we all gave you last year in last semester in 30-1. We gave you one like this. Now, if this is X, then this width is X, then this width is X, then this is X. These are all X's. We agree? Along it? Now, what was the entire width from this piece to this piece? So from here to here. It's 20. But what did I take off of that 20 to get this length? 20 minus 2x. I think people aren't paying attention to me and then are going to ask me these questions after I'm not going to answer them. So this length here is 20 minus 2x. We agree? Now last semester, one of them was 20, I think, and I think one of them was 10. So we did like 20 minus 2x, and then the other one was 10 minus 2x. Remember that? This is a square. So this is 20 minus 2x, and then the width is also 20 minus 2x. Right? So if I fold them this way, you understand. So if I'm making the box and it's like this, those are the lengths. So that's the width of my box, correct? The width of the box here is 20 minus 2x. The width of this side of the box is 20 minus 2x. What's the height? X. That's why you got volume last semester with that weird one that was 20 minus 2x and 10 minus 2x. So this length here, from here to here is actually 20 minus 2x. That's what I've written on the paper, right? And then from here to here, this is 20 minus 2x. And then, in reality, these don't actually exist, right? And then you'd fold that up and you'd make a box. We agree? So then, to get our volume, it is going to be length times width times height. The length is 20 minus 2x. Now, some people will say, okay, well, I'm going to go squared times x. It's not incorrect, right? The length and the width are the same. So we set up a volume equation. So the catch in optimization questions is we're going to get some sort of formula, and we're going to have to derive it, set it equal to 0 to get the critical number for the max and the min, right? Whereas related rates, we got some sort of formula, and then we had to just do the derivative of that formula and have only one thing missing and find that one thing that's missing, right? They're very different. This one has max or min. So how do I know this is an optimization question? Well, it says, cutting square pieces of paper the same size from the largest corners of the sheet and then folding up the sides, find the dimensions of the box with largest volume. That's another way of saying max volume. If I have max or min in the question, it's an optimization word problem. Okay? Which means that I am going to have to differentiate that, set it equal to 0, and get the critical numbers, correct? In that format, is that something nice to differentiate? No. So what are you going to have to do? When I have a squared, I'm going to rewrite it out twice. And then I'm going to have to FOIL, distribute in the x, collect like terms, and then differentiate it. Correct? So try that out. Great. 20 times 20 is what? 400. Minus 40x minus 40x plus 4x squared, and then we have to multiply that all by x. Okay, so we get 400x minus 80x, that's squared, plus 4x cubed. Because you're distributing in the x. Okay, so we're getting critical numbers, correct? We're going to set it equal to 0. I can take out 4 and an x. So I'm left with x squared minus 20x plus 100. Oh, wait. Oh, the tiniest eraser. Why? So we're going to get 0 equals 12x squared minus 160x plus 400. What could I take out? A 4, and I'm left with 3x squared minus 40x plus 100. All right. So then I have to say what multiplies to me 300 and that's going to be negative 40. What do you get? Negative 30 and negative 10. Then I group. And I get 3x, x minus 10, minus 10, x minus 10. So I get 4, x minus 10 and 3x minus 10. X equals 10 and x equals 10/3.
Yeah.
Okay. Now, I need to find the actual dimensions, correct? So I have x, and I have 20 minus 2x's. Okay, cool. I'm going to fill in 10. So I get 10, and then I get 20 minus 2 times 10, which is 0. Is that a box? No. That literally just has a height of 10 on no other objects. So what happens to the 10? It's extraneous. Now, let's try the 10/3. So we have x equals 10/3, and then we have 20 minus 2 times 10/3 is my dimension. So I get 20 minus 20 over 3 times this by 3. So I get 60 over 3 minus 20 over 3, which is 40 over 3. Now what the heck is the units? Centimeters? So here it says, find the dimensions of the box with largest volume. The dimensions of the box with largest volume are 10/3 centimeters by 40 over 3 centimeters by 40 over 3 centimeters. Okay. Then we're flipping over. The next one, if you do not pay attention, I will lose you. Like, not just lose you, you'll be in Narnia. You'll be so lost. Yeah.
Did we say the 10 was extraneous because we don't want it to equal 0?
Well, because then your length and width would be 0, and you can't have a length and width of a 0 on a box, right? It has to have some dimension, so it kicks it out. Yeah. All right. Big thinking caps. This is not that hard, but people will get it wrong. Okay, so here we have a rectangular field adjacent to a, what does adjacent to a river mean? Beside a river. So we have, here's a river, we have a rectangular field adjacent to it. Okay? It is to be enclosed. I enclosed it. Fencing along the river, so here we are fencing the river, correct? Fencing along the river costs $5, so this here is more of a cost. And the fencing on the other sides is $3 per meter. Okay. Perhaps there's a cliff on the river and your cows would all die. So you have to have more extensive fencing. I don't know, but it costs more. Okay. We have to give different lengths and widths to this, correct? So I'm going to do let statements, which I should have done in the other ones, but I'm going to do it here because I'm going to label something different. I'm going to label this one, let's say X. So I'm going to say let X be the length of the fencing parallel to the river. And I'll make these be Y. You could do W's and L's. It doesn't really matter, right? You just kind of have to tell them what it is. So let Y be the length of the fencing perpendicular to the river. Then we're going to keep reading. So that would help us get the perimeter, right? The perimeter would be 2y's plus 2x's, technically, if we want to think about it that way. but we have to put cost on those. So we're going to get a cost equation. So here it says the area of the field is to be 1,200 square meters. So I do know that the area equals what of a rectangle? What's my length and width in this one? X and Y. So I have 1,200 equals X times Y. Now, they want us to find the dimensions of the field that give us the least expensive to enclose. Least expensive means minimum cost. So we need a cost equation. Because each of these cost a different amount, right? Well, 3 of the 4 cost a different amount, okay? So if I go to make myself my cost equation, and why do I know I need a cost equation? Because it wants the minimum cost. If it wants minimum cost, I need a cost equation. I need to find the first derivative of it and get the critical numbers, right? Minimum cost. If it's minimum area, I need to get the area formula, find the first derivative of it, to get the critical numbers. If it's minimum perimeter, I take the perimeter formula, or maximum perimeter, I take the perimeter formula, and then derive it, and then take the critical numbers, okay? So this one says minimum cost. So I need a cost formula. So the cost, I'm going to label as C of, I'm just going to label it C. Sure. Cost formula. Okay. I need to make a cost formula. In order to get a cost formula, $5 is being multiplied by something, plus $3 is being multiplied by something. We agree? What variable is $5 being multiplied by? 1x, right? What sides are being multiplied by $3? A y, an x, and a y. So technically 2y plus x. Two y's and an x. We agree? Now let's distribute it through because it's not as nice. I'm going to drop the dollar signs. So I'm going to get 5x plus 6y plus 3x. And now I have 8x plus 6y. If I differentiate it currently, I'm going to have to do implicit differentiation because I have 2 different variables, right? The key to related rates is you will have different variables. You get like dv over dt, dr over dt, dh over dt, right? The key with optimization problems is before you differentiate, you want to have them all be one variable so that you can differentiate it easily and get a critical number of an x or a critical number of a y or whatever it may be, right? So I either need to get the x to go away or the y to go away. It doesn't matter which one I choose. I just need to make one of them go away and get replaced with the other variable. How am I going to do that? Yeah. The area formula, I can rearrange to what? Either x or y. Which one do you want to do? X. So x equals 1,200 divided by y. Could we go the other way? Could we go y equals 1,200 divided by x and replace it that way? Yeah, it doesn't matter. The one that you're replacing it replaces for. Make sure your phones are not out and you're writing feverishly. Or you can place the other way. So I'm going to get 8 times 1,200 over y plus 6y is my cost formula. What's 8 times 1,200? 9,600 over y plus 6y. 8's over 1. Write it over 1 so you don't distribute the 8 through full. So 9,600 over y is not easy to differentiate right now. How else could I write it? 9,600 y is a negative 1 here. So then I can just do power rule, right? So now to get the minimum cost, I'm going to actually differentiate this. So I'm going to get negative 9,600 y to the negative 2 plus 6. How do I solve? Some people really stink with y to the negative 2, so if it's easier for you, you can rewrite it like this. Either way, though, I need to move that 6 over first, correct? So I'm going to get negative 6. That doesn't even look like 6. That's worse. Okay, negative 6 equals negative 9,600 y squared. Then what do? Bring the y squared up, bring the negative 6 down, right? So I get y squared equals negative 9,600 divided by negative 6. So y squared equals it's like 1,600. Yeah. Square root plus or minus. So y equals positive and negative what? 1,600, taking the square root of it. Square root of yeah. You said 400, then 40, then 4. And okay. So this one's good. This one is extraneous. How do I get the other one? How do I get the other value? Plug it back here. X equals 1,200 divided by 40, and what do we get? 30. Now let's find out what the heck it wants. It wants to find the dimensions. And what are these dimensions in what? What unit? The dimensions are in what? Meters. So the dimensions of the field that is the least expensive to enclose are 30 meters by 40 meters. So remember that the question, whatever's in the question is the one that you're going to differentiate, correct? So this one here says a rectangular playing field is an area of this. So I know length times width is 600. I know that. It says fencing is required to enclose the field and divide it into 2 halves. Find the minimum amount of fencing. So they're making me find the minimum amount of fencing. So that's perimeter. So I know that I'm going to have to take the perimeter formula and do the first derivative of it. Okay, so whatever you ask for minimum cost, you find the cost formula, do the derivative of it. If it says minimum or maximum area, then you take the area formula and find the derivative of it. So this is my perimeter formula, which is just lovely this time of year. However, it has 2 variables in it, and I want to differentiate and get a critical number. Critical number comes from 1 variable, right? So I need to replace something in here. So they had to have given me other information. Well, here they gave me length times width is 600. So I can isolate for one of them. Okay? So say I go length equals 600 divided by W. Well, now I can plug that into the perimeter formula. So I get 3W plus 2 times 600 over W. I know there's lots of you who try and distribute that 2 through both of them. If you are that person, and you know you are, always put a 1 underneath so that you don't distribute the 2 through. Okay? So then we get perimeter equals 3W plus 1,200 over W, which I told you to rewrite differently, correct? So P equals 3W plus 1,200 W negative 1. Then we have to do what?
There's some solicitors outside the door.
They're my other solicitors. Someone with a squeak. I don't want to know. So, if we want the maximum perimeter or minimum amount of fencing, we're going to take the derivative of this, set it equal to 0. So I get 3W minus 1,200. 1,200. Yeah, 1200 over W squared, or W negative 2. Then same thing we did before. We have to bring that 3 over first. So I get negative 3 equals negative 1200 divided by W squared. Then what do? Bring the W squared up by multiplication and the negative 3 down by division. So I get W squared equals negative 1200 divided by negative 3. And W equals what? Oh boy. What is 12 divided by 3? 4. And then there still have what? 2 zeros. So it's 420. Okay. Then I have to square root. And W equals 20 meters. And W equals negative 20 meters. Well, this one is extraneous. How do I get the length? Sub in for L. 600 divided by 20, which equals 30 meters. So find the minimum amount of fencing. The minimum amount of fencing I haven't found yet. How do I find the minimum amount of fencing?
30 times.
What is my perimeter formula? 3W plus 2L. So it's 3 times 20 meters plus 2 times 30 meters, which is 120 meters. Yeah?
Yeah.